Yeah. Good afternoon, everyone. How are you doing? Long day and last session of the day. Let's clap for yourself for making to the day. My name is Siba. I'm a solutions architect at AWS, and my colleague Alex. We're going to talk about a topic which is challenging, at the same time very, very exciting: how to secure generative AI. And before I start, let me ask a couple of questions to you. How many of you have moved a workload, generative AI workload to production? Raise your hands if you have moved a workload to production. OK. How many of you are building a generative AI workload right now? Some of you. And how many of you think security is one of the most critical and challenging part from moving POC? POCs are easy. From moving to production, they are one of the most challenging part. How many of you think? All of you. We all are in the same boat. So we are going to explore what we think or how we approach to secure generative AI on AWS. So thank you for joining again. It means the session is important for you. So Alex and I have a goal that we give you some key insights that you can apply right away. So this is the agenda for today. We're going to talk about how we at AWS think about security and responsible AI. And then we're going to go through the generative AI tech stack, and we're going to talk about what security features are built in and what controls we give you to build on top of what we already provide. And at the end, we talk about how to integrate AWS security features, AWS security services into your generative AI application. We know now generative AI is bringing new worlds of possibility, new innovations. At the same time, it is bringing new risks and new challenges. The risks and challenges because the way it interacts with data, your data, the way you or users interact with generative AI system. And when we think about responsible AI, we think in 8 dimensions, starting from fairness. What is fairness? Fairness talks about how to reduce biasness in your system output to data privacy, governance, transparency, and so on. How many of you feel overwhelmed looking at this slide? I feel overwhelmed. It's too much. It's a lot to consider. So let's simplify this. So if you decompose responsible AI, you can put in 2 categories or two ways. One is safety. What is safety? Safety is about preventing harmful and inaccurate system output. The challenge here is that you can handle this risk probabilistically. And you need to do risk assessment, and you need to understand your risk, how much risk you can accept. You can handle this through some application of services like Amazon Bedrock Guardrail that Alex is going to talk today. And then security. What is security and how is it different from safety? Security is about preventing leaking of sensitive or confidential information. The good news here is that our good old friend, traditional security, applies here. Why traditional security? They are deterministic in nature. They are auditable. They are explainable. And you need to filter the data before it enters to your AI system, because anything that goes into the model weights, anything that goes into AI system can and will come out. So you need to filter the data before it enters into AI system. So we're going to talk a lot about security today. So before we talk about responsible AI and security, now let's classify our generative AI use case and our application. And why this is important, based on which scope it belongs to, the security controls will vary. So on a high level, we built a security scoping matrix which talks about 5 scopes. Scope 1 talks about consumer applications, where you're using some applications like ChatGPT or our own PartyRock. In scope 2, you're using AI with enterprise applications like Salesforce, Confluence, or our own Amazon Q. In scope 3, you're using pre-trained model or off-the-shelf model, and you're building custom applications using techniques like RAG and agents. How many of you are familiar with RAG and agents? A lot of you. So that is scope 3. Scope 4 is when you're fine-tuning a model with your own data, and scope 5 is when you're building a model from the scratch. And if you see, in scope 1 and 2, you have buyer persona. Scope 3, 4, 5, you have builder persona. And if you have also seen, you have, in scope 1, you have least access to your proprietary data, and scope 5 has maximum approach to your proprietary data. And all these scopes require some varied controls of different security disciplines like governance, like risk assessment, like resiliency and controls, right? You need varied controls. And you have been doing this, not just for generative AI application, for non-generative AI applications, you're doing this, right? So if it is a external application or internal application, whether you're processing customer data or not, whether you're processing sensitive information or not, you use different levels of controls, security controls for your non-generative AI applications as well. So if you want to go deeper into security scoping metrics, you can go through this blog. You can take a photo or scan this QR code. I'll give you a second. Now, moving on. So how many of you have seen this generative AI tech stack today? A lot of you. So we're going to go through each layer of our generative AI tech stack, and you may have guessed. So our top layer, which is Amazon Q services built on Bedrock, which is our tooling layer. Bedrock provides access to multiple foundation models and also gives you a lot of features like knowledge bases, agents, and so on. And Bedrock is built on our foundation layer, our infrastructure layer, which gives two foundational components. So let's start with our infrastructure layer. So, and when do you interact with an infrastructure layer? When you're building your model from the scratch, when you're fine-tuning a model, when you are running your custom model, or when you're doing a custom data processing pipeline on top of Amazon EC2 instances. There you need GPUs or our own silicon like Trainium, Inferencia, and most of these instances are built on AWS own Nitro system. So, and how do we secure AI infrastructure? And when we think about securing AI infrastructure, we think in 3 steps. One is that how the AI system and data is isolated from the infrastructure operator. This is critical. How it is isolated from infrastructure operator, it means us. And how the AI system and data, your AI system and data isolated from yourself. Let me repeat, how it is isolated from yourself. We'll go in details today. And how the communication is protected. Again, there is a blog post that goes deeper. We'll talk a lot about all of the three points today. So confidential computing is not something new. This is an industry term, but we think slightly differently than others. So by confidential computing, we think about 2 dimensions. Dimension 1 talks about how your AI system and data is isolated from infrastructure operator, that is us, right? And we built AWS Nitro systems to build dimension 1. And dimension 2 is enabled through Nitro enclaves, and that allows you to isolate your AI system, your data from yourself. And let me explain what it means isolating from yourself. Imagine the security boundary of Amazon EC2 instances. You have your general purpose applications using third-party libraries or open public libraries. And within the same EC2 instances, you have sensitive applications and sensitive data. Can a vulnerability or weakness in third-party library access your critical data running within the same EC2 instances? If the answer is yes, you need to build that boundaries. And we built Nitro enclaves to enable you to do that. So remember, dimension 1 is isolating your system data from infrastructure operator, in this case, AWS. And dimension 2 is isolating your AI system data from yourself. Now, if you do not know what is AWS Nitro system, how many of you are using AWS Amazon EC2 instances pre-2018? Have you launched EC2 instances before 2018? So if anyone used Amazon EC2 instances before 2018, it was built on Zen hypervisor. And the pink squares on the top, those are Amazon EC2 instances. And it had a big virtual machine. We call it DOM0. And what is DOM0? It ran a privileged copy of the operating system, which runs the stack like local storage, EBS storage, networking stack like VPC, security groups, and monitoring, all the monitoring services. And we have been working on to move these components from the host to reduce jitter in your EC2 instances. And the journey ended here. If you see, it is very simplified, right? There is a thin hypervisor and is Amazon EC2 instances. What it means, and where the components went, the components move to a dedicated card called Nitro cards. They have their own CPU memory. We'll go a bit deeper into Nitro cards a little later. And they are connected to the host system through PCIe. And Nitro system has 3 core components. The Nitro cards, they are stars of the show. They run local NVMe storage. They run EBS storage, networking stack, monitoring stack that run within the hypervisor before. And they are separate cards. And they have their own resources like CPU memory, and they are built on our own silicon Nitro chips. And then there is Nitro security chip. There is a small component embedded into system mainboard, and also the Nitro cards. And what it does, it secures the boot process through hardware root of trust. It extends hardware root of trust to the system mainboard, and it allows us to know what exactly running in any host in any facility in anywhere in the world. And then Nitro hypervisor. That is a custom-made, lightweight hypervisor built just for AWS. And the job is just to do CPU and memory allocation and get out of the way. And the benefit for you get bare metal-like performance. The benefits, so Nitro, all the communications are encrypted so that you don't need to add another layer of encryption. It secures the boot process with the help of Nitro security chip we talked about, and live patching. We can patch all the components of Nitro system live without any impact to your instances. And most important part, no operator access. Let me explain. There is no access to Nitro system. There is no shell. There is no general purpose access. All the operations done remotely through system, in very, very rare cases through human operators. And when human operators perform, they have access to very limited set of administrative APIs. And those APIs are logged, authenticated, authorized, and audited. And none of those APIs give access to your data. This is very important. And if you're talking about AI use cases, typically use one of the accelerated instances built on our own silicon, like Trainium Inferencia, or silicons from our partners. All these instances are built on Nitro. What it means that they have the same security foundation we just talked about, and they give those performance benefits of Nitro system. If you want to go deeper, you can go through the white paper to understand Nitro security architecture. We had third-party group, NCC group, validate our Nitro security architecture. You can find the report here and the QR code in the middle. And on the right, we didn't just stop there. We updated our service terms to clearly state that there is no absolute operator access to Nitro system. So it's clearly stated in our service terms. Why we are telling this? Why am I telling this to you? And why this is important for you? So when you're talking about processing sensitive information, processing confidential information, you need to ensure the infrastructure you're using is secure. And how secure? And what we are doing on our side of the responsibility. Now let's go into what we give you as feature to build on your side of responsibility. So there are two key capabilities that is part of, again, Nitro system. One is Nitro TPM. That is standard compliant trusted platform module, standard TPM 2.0 device available to EC2 instances. And it runs the cryptographic operations within EC2 instance. What it can do, it works with Nitro security chip we talked about, and it secures the boot process. And it can gather and store EC2 instance state, and that you can use to attest its state, prove its identity to a remote system. For example, if you have two systems communicating with each other, you say, perform operation X only if the instance state is Y, which you have gathered before, right? So ensure the identity or validity of instance identity. And Nitro Enclave allows you to give dimension 2, where you can use to isolate your AI system data from yourself within the same Amazon EC2 security boundary. So look at this feature. So both belong to the same EC2 instance. So Enclave is built by borrowing CPU and memory resource from the parent EC2 instance. It is connected to the parent EC2 instance. It can only be accessed through parent EC2 instance. And if you see that it has a secure channel from the parent EC2 instance, think like the parent EC2 instance works as a proxy to Nitro Enclave. Nitro Enclave has no access to storage, no access to networking. And you can choose the CPU and memory you need to build your Enclave based on your application need. And it has first-class integration with AWS Key Management Service. And why it is important that if you know KMS, you can add KMS policies, and within the policies, you can add conditions. If you set a condition which says that perform encryption, encrypt, and decrypt operations only when Enclave ID is X, it means all the cryptographic operations can be performed by a specific Enclave application when the Enclave ID matches. And you get all these benefits at no additional cost. So what we talked so far, we talked about first how to classify your generative AI application. So there are five use cases, and this is important to understand what level of security and security controls you need based on your use case, based on the scope the use case belongs to. And after that, we talked about which component you need for your use case, whether if you need the infrastructure layer to build your application. We talked about what we are doing on our side of the responsibility, isolating your AI system data from AWS operator, and what features we give you, like Nitro Enclave, Nitro TPM, to build dimension 2, like to isolate your AI system data from your general purpose application. With this, I'm going to hand over to Alex, who will talk about the upper two layers. Thank you, Alex.
Thank you very much, Siba, for walking us through the infrastructure layer. My name is Alex. I'm a Solutions Architect Manager at AWS, and I'm going to walk you through the tooling layer and the application layer. So now let's go a little bit higher. On the middle layer, we are offering actually organizations access to foundational models and large language models with a really diverse set of those foundational models. And for achieving this, we have built Amazon Bedrock. Raise your hand if you're familiar or already using Amazon Bedrock. That's great to see. For those who are not familiar with Amazon Bedrock is our fully managed service where you can access a variety of foundational models from leading foundational model providers via a single API. And we have also built Amazon Bedrock, obviously, with privacy and security and safety in mind. And why we want to offer this kind of variety of foundational models is because customers are telling us that they want choice. Especially in the times of Gen AI, this is really crucial. Why? Because customers want to use the right foundational model for their job. And that is why they need to experiment a lot to see which foundational model fits best. And that is the reason why you can actually access foundational models from leading foundational model providers such as Anthropic, Mistral, Amazon, and others. And we're not stopping here. We are definitely going to continue to add more foundational model providers to it. But let's emphasize a little bit on the security, privacy, and safety part of Amazon Bedrock itself. Amazon Bedrock keeps your data secure. And if there's one key thing you should take out from the session, is that none of the customer data is used to train the underlying model. That is really the key takeaway you should get out of the session. Furthermore, all the data at rest is encrypted, leveraging AWS Key Management Service, and encrypted in transit, leveraging a minimum of TLS 1.2. If you want to have an additional layer of security in your transport layer, you can leverage AWS Private Link, where you can create a private connection, leveraging VPC endpoints and privately accessing the Amazon Bedrock service. Also, if it comes down to customization, the fine-tuning, for example, the fine-tuned models itself are encrypted, as well as the data you're using remains within the region, within the VPC, and only you have access to it. Furthermore, if you're familiar with AWS IAM, Identity and Access Management, you can also use it to position or to create fine-tuned or fine-grained access controls. And you can leverage Amazon Guard Duty for threat detection. And Amazon Bedrock is also following a couple of compliance standards, which I will dive deeper a little bit in a couple of minutes. Now, let me make an example to showcase you how we really ensure that none of the customer data is actually inadvertently leaked or misused. So therefore, I want to walk you through the data flow of Amazon Bedrock. So what we have here is a classical setup. So you have a customer AWS account where you have a custom VPC. A client is running in and wants to access the API endpoint of Amazon Bedrock, as well as maybe there is a corporate network where you have as well a client accessing or wanting to access the Amazon API endpoint. So now, how can you do that? There are two different ways, obviously. One is leveraging the public endpoint. So for example, from the corporate network, you can use or traversing the internet and accessing then the public endpoint of Amazon Bedrock service, or leveraging within the customer VPC from the client a NAT gateway, network address translator gateway, to access as well the Amazon Bedrock endpoint. The other way would be to make it private. So again, from a corporate network, you can leverage a dedicated connection with AWS Direct Connect connection and traverse actually the AWS network backbone and not the internet, leveraging an AWS private link to access the private endpoint of the Amazon Bedrock service account. And as you can see, there is another AWS account really operated and owned by AWS where the Amazon Bedrock service itself is running. Now, there's much more to it. What about the models? What about the on-demand compute we need to do the inference? Well, this is in a so-called model deployment account, which is a separate AWS account, again, operated by AWS, where we store all the model artifacts in an Amazon S3 bucket, and also we maintain there the on-demand compute. Well, that is true for first-party models, but what about third-party models? Well, there's, again, another AWS account operated by the foundational model provider. They store their artifacts, their model artifacts, in an Amazon S3 bucket. And whenever there comes a request in, saying I want to use maybe a model from Anthropic, we do a deep copy from the model staging account, from the Amazon S3 bucket, to the model deployment account, which is operated by AWS and owned by AWS, and then run the inference with that. And following the least privilege principle and having the separation of the AWS accounts, that is the reason why the foundational model providers can't access the data, nor is AWS able to access customer data, because that remains within the region and within the account and the VPC you have created or you stored your application, your data, sorry. Furthermore, you can make it more secure leveraging existing AWS security services such as AWS IAM, Amazon CloudWatch, for example, AWS CloudTrail, or the before mentioned Amazon Guard Duty. Now that you have understood a little bit in terms of like how we make sure how the Amazon Bedrock data flow looks like, we also have to think about governance and auditability. Because you want to understand what is going on within your GenAI application. You want to exactly know when there is an issue and you want to troubleshoot that. And Amazon Bedrock integrates very well with Amazon CloudWatch, for example, where you can track usage metrics or build your customized dashboards, but also you can enable model logging, for example. You can understand what is going on with your knowledge base, with your agents. So those are built-in mechanisms you have with Amazon CloudWatch. With AWS CloudTrail, you can use it to monitor your API activity and use it for troubleshooting issues and understanding quickly, okay, what kind of requests have been made and where should I look for it. And the compliance standards I mentioned, I highlighted some of them which are really important as well in the European area, C5, GDPR, obviously, SOC 123 or PCI. We are following all those standards, which are also important for auditability reasons. Now, when it comes down to GenAI security, we have seen, okay, we can access the foundational models via Amazon Bedrock. We have to think a little bit about our encryption. We have also to think about our network controls. But the point is, and also Siba mentioned it already, decomposing responsible AI, and there's much more to think about. Raise your hand if you have seen an iceberg slide today. Great. We at Amazon, we do love icebergs. Why? Because that's just the tip of the iceberg. There's much more to consider below. And even though it's so obvious, it is not always so obvious to, or surfaced so obviously. That means you have to consider as well the security and safety of your data. Before I jump into the topic of, or show you how you can actually secure and save as well the access to the data, let me walk you through how you can make your GenAI application work with the data, because there are different methods in place. Well, there's RAG, Retrieval Augmented Generation, where you can leverage some kind of context, augment your prompt, and get a more tailored answer from the foundational model. This is really a common standard already, where you don't want to rely only on the trained large language model knowledge, but furthermore want to contextualize it. Model customization comes in different flavors. For example, fine-tuning, where you're leveraging labeled data to improve the model performance for a specific task, or continued pre-training, where you're leveraging unlabeled data and pre-train this model so that you ingrain this new knowledge into the large language model. But there are agents as well. And with agents, you now have also coming into play a lot of more complex access, let's say with third-party APIs, or with knowledge bases, or even with tools. So those are just some examples. There are definitely more. But you see already there are different ways of how to access or how to make your data work with your GenAI application. But now let's talk about why this is important and why you should care about. Siba mentioned earlier in his part that traditional security mechanisms also apply for GenAI applications. So you don't have to reinvent the wheel, which is really great. And what we mean by that is with this picture here. So assume you have the following situation, and assume you will wait until you do your authorization until you're accessing the foundational model. Well, technically, you could do that, absolutely, but you don't want to do this because that might be too late. Why? Because you don't want the AI let make a clear statement about like if a user is authorized to even leverage the data or not. And that means our recommendation is to do authentication and authorization as early as possible. Ideally, when the user interacts with the GenAI application, and there you pass over then, let's say, key value pairs, scopes, claims, tokens, whatever you want to call it, to your downstream components. With that, you really ensure that at every single step, you can access the right data, and you're not inadvertently leaking that data or performing any actions which are not authorized or the user is not authorized. Therefore, please do authorization as early as possible. We have talked about security, but we haven't covered safety yet. And this is where Amazon Bedrock Guardrails comes into place, because you also want to make sure that the responses and the data itself is safe. What do we mean by that? So, for example, you can, with Amazon Bedrock Guardrails, you can evaluate the prompts and the model responses across different features. So with agents, with knowledge bases, or plain with, let's say, the foundational model itself. You're also able to define thresholds to filter out harmful content, so that you really want to avoid that kind of harmful content. Oops, nevertheless. You can define and disallow specific topics, denied topics. For example, where you say, I want to adhere to some kind of company brand where some words should not be included. And you can also detect personally identifiable information, which helps you to remove that sensitive information from your GenAI application. And you're also able to leverage groundness of the responses and filter out hallucinations of the responses itself. And how it works is quite simple, to be honest. So you see on the left-hand side, there's the user input, the prompt. What happens under the hood? The guardrails are applied. So you see there are different ways of filters. And those guardrails then are applied to the input, made it safe. Then the foundational model inference is happening. And the output of the foundational model will also be used, and we also apply then the guardrails again, so that we can provide a safe response to the end user. Great, we covered the middle layer, which is our tooling layer. Now let's move up to the top layer. And the top layer is really for organizations who might not be familiar and don't have the expertise on GenAI, on RAG, on agents, and all these kind of fancy stuff. But they want also to build, and they don't want to build GenAI applications from scratch, so they want to start somewhere. And they have also the strong belief that GenAI is important for their enterprises and for their business. And that is the reason why we have built Amazon Q. And Amazon Q sits there where it should be used. So there are different flavors, as you currently can see. Let me walk a little bit through Amazon Q Business, which helps you actually to provide some kind of chatbot functionality to chat with enterprise data, for example. So what you can see in the screenshot is exactly that chatbot functionality, and it delivers you quick and accurate answers tailored to, for example, your enterprise data. And it also respects existing access controls, leveraging your single sign-on, for example. And as I've mentioned, you can also bound it to enterprise data because there are connectors for over 40 popular data sources, such as Amazon S3, Salesforce, Google Drive, for example, and many more. And we have talked about the guardrails for a couple of minutes ago. Administrators are also to implement or apply those guardrails to adhere to company standards, or also to make actually the data or the responses and the input safe. So, talking about safety, you have a pre-built guardrail for toxicity in place, and you can also specify further topics and words just to adhere, for example, to company compliance standards, such as that you want to avoid any kind of input or output about your competitors, for example. But also you can deny words to filter exactly those harmful content. It also respects access controls, as mentioned before, and you can only restrict it for to get responses which are related to your enterprise data rather than, let's say, general knowledge. About security, nothing new here, to be honest, because there are same mechanisms in place as you might be already familiar with other AWS services and as you have seen with Amazon Bedrock. So you can leverage as well AWS Private Link to make a secure connection. It integrates with AWS IAM Identity Center to adhere to fine-grained access controls. Also, AWS CloudTrail is in place to track your API activities and use it for troubleshooting. And Amazon Q Business itself is also adhering to different compliance standards. And I might be repeating myself as well as Siba, but nevertheless, we want to emphasize that none of the data is used to train the underlying model, and that is also true for Amazon Q Business, because Amazon Q Business is using a pre-trained machine learning model, and none of the customer data is actually used to fine-tune or customize that kind of underlying machine learning model. We're also leveraging encryption at rest with AWS KMS and at transit with a minimum of TLS 1.2. And specifically for Amazon Q Business, because it is a regional service, the data remains in the region where you create your Amazon Q app. As we have covered now the middle layer and the top layer, as well as the infrastructure layer, I'm handing over to Siba to put all the things together. Thank you.
Thank you, Alex. So we have covered all three layers. We talked about what we are doing on our side of responsibility, and also what are the features we give you for you to either add or tune, right? So let's put all of them together. So the key message is that you need to build your defense in-depth security strategy. Imagine you are general of an army, and your task is to protect the crown jewel or the castle in the center. So what do? You build multiple layers or multiple perimeters of security. And you have been using this, right, for your non-generative AI application, like data protection, like you encrypt your data, you follow application security best practices, you have infrastructure security like the WAF or any other infrastructure security services. And on top of that, you also have you add ability to detect threat and also respond to incident. You add identity authorization and authentication, and you add network protection. On top of that, you have the policies, procedure, and governance, right? So this traditional security measures do apply in a new. So this is a new context. You just need to adapt to new context. But the traditional security controls still apply. And why this is important, I talked about. Because you want to bring deterministic nature to your application, to a system which is largely undeterministic, right? And you also need to make sure this is auditable and explainable. So the key message is that apply traditional security, but keep it outside your AI system. Why? I think Alex covered this already. You don't let AI decide your fine-grained access control. It means like, okay, I'm user X, and can you give me access? And the AI says, no. Are you sure? It should still be no, right? But the hallucination shouldn't allow, okay, I'm wrong, I'll allow you. No. So you need to bring deterministic nature by using traditional security controls. And you need to filter all your data or PII or the sensitive data before it enters to your AI system. Again, because anything that goes to model weights can and will come out. And how do you do that? We provide depth and breadth of security services to build on top of that. For example, S3. S3 is scalable, secure, and durable storage service. Then there is backup and the networking and observability stack, like CloudTrail we talked about, which allows you to audit API operations, CloudWatch logs, which gives you logs for invocation logs from Bedrock, where you can understand all the prompts, all the responses, latency, token usage, everything. And on top of that, AWS security services like for authentication, authorization, for data encryption, and threat detection and incident response we just talked about. And on top of that, multiple AI services for you to quickly build generative AI and secure generative AI applications. There are some resources if you want to take a picture here, talking about secure AWS approach to secure generative AI and different related features. Again, if you have any questions around our AWS European Sovereign Cloud, feel free to reach out to our colleagues in Hall A1. And thank you. Thank you for joining this session at the end of the day. I hope this was useful for you. Please take a few seconds to give us feedback, how we did and what we can improve. And we'll be here after this session if you have any questions. Thank you again. Enjoy your rest of the day.